Now suppose we have to choose a random number and a real number, not necessarily a whole number, between 0 and 2. So these are some examples of numbers between 0 and 2. Real numbers, not necessarily whole numbers. So we have 0.1249, for example, or 1.333333 ... recurring. Square root of 1.5. These are all examples of real numbers between 0 and 2. And this tells us that the variable, that the number that you pick could be any of these real numbers between, starting from 0 until 2 on the number line. So the variable is continuous. And in the case of a continuous variable, we find the probability of a certain event by finding the area under the curve, right? And what do we mean by curve? We look at, for example, we can get a random number generator to find numbers between 0 and 2. And it'll keep producing numbers between 0 and 2, and we make a distribution out of it. So for example, it could look like, let's say the numbers are between 0 and 0.2, 0.2, 0.3, and so on. And we put the counts here, and the counts come here. So this is the distribution, and then with that distribution we make a histogram. And since every number is equally likely, there will be no difference in the heights. Roughly, the heights of the bars will be the same, and that's how we get a rectangular distribution. So the shape of the distribution is not bell-shaped because every number is equally likely to be picked. So therefore, it is, all the bars are of equal height, and therefore we get a shape that is rectangular. Remember that the total probability of a legitimate probability distribution is 1. That's the total probability. If it's a legitimate distribution, then the total probability is 1. So since area equals probability in the case of a continuous random variable, the shaded area under the curve, shaded in yellow, is equal to 1. Okay. So the base goes from 0 to 2. So 2 minus 0 is the measurement of the base. So that's your base. The height, let's say we call it h because we don't know what it is, and this is equal to area. We need to know the height. So area equals base times height. So area is always 1. The total area is always 1. The base is 2 in this case because we are picking a number from 0 to 2 times h. Now we solve for h by dividing both sides by 2. And that's how we get h equals half. So now if we have to find, let's say the area under the curve, say this is 0.5 since that's a 1. So what we're trying to find is the probability that x, the number that is picked, is greater than 0.5, for example. Which means, notice what I'm shading here. I need to figure out the total area that I've shaded in red. And that is, again, a rectangle. So it's base times height. We already know that the height is half. We figured it out here. The height is always the same. The base is from 0.5 to 2. So take the higher number, subtract the lower number, and that gives us the measurement of the base times height, which is half. So this is 1.5 times 2, and that is 0. Times half, I'm sorry. So that is 0.75, and you cancel the 2 with 1.5. Just use your calculator. That will be 0.75. So that's a half, not a 2. So this is how you calculate the area. And why do we care about the area? because the area is equal to the probability. Now suppose we have to find the probability that the random variable x lies between 0.5 and let's say 0.75. So all we have to do is go from 0.5, so I'm going to shade it in this. We go up to 0.75, which is about here, and we find the area in between, right? It's again a rectangle, so we go base times height. Height is always the same because we are picking a number between 0 and 2. The height is half, and the base is, this is 0.75, so that is 0.75, the larger number minus the smaller number, and that is equal to 0.25 times half, which is 0.25 divided by 2, so that is 0.125, and that is the probability.